Now we have a GoNet represented by the Go 159, encompassing Go 156, 157, and 158. 157 currently is not added into this GoNet. However, in order to add this Go 157 in, we place transitions and arcs. In order to go from one state to the next in the agent mental state, the agent has to go through a transition. A transition is basically a set of tasks organized into a task list. Each task contains a set of functions defined by the user. They can either be functions from a dir file, or they can be functions from web services. To connect the goals and transitions, we place arcs in. Arcs are directed lines signifying the direction of flow of the logic of the agent mental state. Now we have a very simple complete GoNet, which consists of 3 states and 2 transitions. This facility here is for us to move the items of the GoNet around on the screen so that we can organize it into a more visually appealing layout. The numbers here doesn't make any sense to the user. It's just a number arbitrarily assigned at the creation of the goal or transition. In order to change the properties of a goal or transition, we can select the target goal or transition, the target item, and use this property panel here, the property grid item, to edit the details concerning this entity. We can change the name of the state. For example, we call it start, and we can give it a description, start state. There are some entities which are allowed to be changed, and some others, like the position and size, which are deemed off, are not to be modified within this property grid. However, they can be modified by moving the item around the canvas. Achievement and cost are some metrics for measuring the cost of going through this state. For example, in this case of the cost here, if we use a goal selection algorithm, such as a fast goal selection or best goal selection, we can use cost as a measure of how costly we go through this state. Here we assign a value of 10 here. Upon creating this GoNet, the GoNet actually has several properties which are able to be edited with this GoNet designer. The name and description, and also the goal selection type. The goal selection type, we have 2 built-in goal selection types, the fast goal selection or best goal selection. These 2 choices, after being made by the user, are made use by the made runtime system when it executes the data acquired with this GoNet designer. Transitions also has properties to be edited. We can change the name of the transition. And this achievement goal, the exception state ID, also the built-in internal variables for goal selection algorithms. The input arcs here just show how many arcs, the IDs of the arcs, which are the inputs to this transition, and output arcs also the same thing. Composite state also has some properties. It has this property called is composite. It actually is present for all the states. This enables the user to change a simple state, atomic state, to a composite state, or vice versa. For example, after these steps, we discover that this state 157 can be further decomposed into a subset of states. In order to better represent this design, we can add in more states below, for example, and we can change the property of this state 157 from atomic state to a composite state by choosing true for each composite, and then we will be prompted to enter the start and end state IDs. After that, we rearrange these states. A transition actually can take multiple input and output states. For example, here we place a transition 94 and we let the state 556 go through transition 94. After that, both states 161 and state 162 will be triggered. This layout means after going through transition 94, after executing the functions contained in this transition, both states 161 and 162 will become valid. And we can place two transitions here in this case to let each state to perform different set of functions and reach the end state 163. The tree view list on the right hand side contains a set of all the transitions placed within this design. We can select the transitions from this view. It will be highlighted on the drawing canvas, or we can select by clicking at the actual transition representation, and this side of the tree view will be updated. This is also true for states and arcs. After these steps, we save the design by pressing the save button. However, the design is incomplete because we didn't place any function or task in any of the transitions. And the GoNet designer actually performs a checking operation just before saving the design of the user. If any error is detected, it will prompt the user what the error is and remind the user that the design currently is not working. If it is fed into the mate system, it will not be run successfully. We can view the design in different manners. For example, we can choose to hide the IDs of the states, or we can choose to hide both the IDs and the names, just leave the shapes untouched. The tree views on this side and the toolbars are also able to be hidden or to be shown